Welcome, guys. In this video, we are going to study the chain rule. If g is differentiable at x and f is differentiable at g at x, so function f is a function of g of x, then the composition f of g of x is differentiable at x. So we know this from previous lectures. And if we denote y as a function of f of g of x and u as function g of x, and then y is a function of u, then we can find derivative of function y by dx using the following rule. It is equal to di over du multiplied by du over dx. Let's show why this is true. So we need to find derivative of dy by dx using limit definition of derivatives. This is delta x. This is limit as delta x is approaching to 0 of delta y over delta x. Now let's do the following trick. Let's multiply and divide by delta u. So this is now limit as delta x is approaching to 0. So we are going to split the following product of two limit of product of the following two fractions into product of limits in the following way. So this is limit when delta x is approaching to 0 of delta y over delta u multiplied by limit when delta x is approaching to 0 of delta u over delta x. So we did it in the following manner. We grouped those two terms together, and we merged those two terms into the following fraction. Now we are allowed to do so since first, this limit represents derivative of u, and we know u is a function of u is a g of x, and g of x is differentiable at x. So this limit here exists. Now this limit here, let's work a little bit on it. So u is a function of x. U is g of x. In case when g of x is differentiable at point x, small changes in values of x correspond to small changes in values of g of x. In other words, as delta x is approaching to 0, delta y, or delta u in this case, delta u is going to approach to 0. So we can replace delta x by delta u. So this limit as delta u is approaching to 0 of delta y over delta u represents derivative of y. And we know that y is a function f of g of x, and it is differentiable. So we are allowed to split them up in the following manner. Now here, this is derivative of dy by du, and that is derivative of du by dx, right? Which was required to prove. Okay, now this is in another form. We can write down our chain rule. So f is a function of u and u is a function of x. Then derivative of f of u by dx is equal to f prime of u. So derivative of function u by of function f by du multiplied by du over dx. So using this formula here, we can derive some common derivatives of trigonometric functions and power functions that we have studied so far. They are very similar. This time we multiply it by term du over dx, since our function sign is now function of u, and function of u is a function of x. All right, let's take a look at a couple of examples. So here we have composition of the following functions. Let's call tan as an outside function. So this is our function of function f, and function f is a function of g of x. Here is our g of x. G of x is a function of x and is equal to x squared plus 1. Now let's take derivative of tangent of x squared plus 1. We start by moving by taking derivatives of outer functions and moving inside and taking derivatives of inside functions. So our outside function is a tangent of x squared plus 1. So we take its derivative at x squared plus 1. So derivative of, we can, for simplicity, replace that x squared plus 1 for now as, let's say, theta. Then derivative of tangent of theta is secant of theta. And let's substitute x squared plus 1 instead of theta back. So we'll get secant of x squared plus 1. So this is our outside function. Now let's take derivative of our inside function, which we denoted as theta. Our theta is equal to x squared plus 1, and derivative of that by dx is 2x multiplied by 2x. So here is our answer. All right, next problem. Now this problem is a bit more complex. This time we start by an outer function, which is sine of some, let's again call that theta. Then we have theta, which is 1 plus cosine of x. And theta can be written down as a root of u, square root of u, where u is a function of x. So theta is a function of u, and u here is a function of x, which is represented as 1 plus cosine of x. Okay, now let's start moving from our outer functions and taking derivatives of those and moving towards the inside functions. Then we'll have derivative of sine of theta, which is cosine of theta, and instead of theta, we'll substitute back a root of 1 plus cosine of x. So we'll start by cosine of 1, root of 1 plus cosine of x. So this is our derivative of outer function multiplied by, the next inside function is root of u. Derivative of root of u is 1 over 2 divided by root of u. So derivative of theta is 1 of 2 root of u. Now substituting u as 1 plus cosine of x back, we'll get 1 over 2 root of 1 plus cosine of x. All right, now the most inside function we have here is 1 plus cosine of x. And this is function of x. Derivative of that is minus sine of x. Okay, guys, that pretty much concludes our lecture on chain rule. We'll use this rule when solving our next practice sheet. Thanks for coming.